Good day everyone, I am Victor, moderator for this webinar. I welcome everyone for today's webinar, which is Verification and Validation, Product Equipment and Process Software and QMS. I would now like to introduce our presenter for today, John E. Lincoln. John E. Lincoln is the principal of J.E. Lincoln and Associates LLC, a consulting company with over 40 years of experience in U.S.FDA regulated industry, 26 as an independent consultant. He specializes in quality assurance, regulatory affairs, QMS problem remediation, and FDA responses submissions, process product and equipment including QMS and software validations. Now I'd like to hand over the floor to the speaker. Over to you, John.
Thank you, Victor, and thank you all for attending. Now, what we'll be doing, this is approximately 8 hours. We're going to start with a discussion of Master Verification and Validation Planning, MVP, and that'll be a general discussion of verification and validation in general, covering all kinds of areas, equipment, process validation, software validation, firmware validation, quality management system validation, etc. So it'll be a very general overview, kind of set the stage for the entire remaining discussion. We'll be looking at various test cases. So the first section will be about an hour and a half. It'll cover the master validation planning, verification validation, including my definitions for those terms. We'll get into design control and product V&V, and then we'll get into product risk management, our session 4, and that will be dealing with software firmware verification and validation. Then we get into session 5, and that deals with human factors and use engineering. And then we'll talk about cybersecurity. Then we'll have a short review and summary, and that'll bring us to a conclusion. So let's get into our first one, master validation, planning to meet U.S.FDA and European Union requirements. Now, the FDA over the years has intensified its emphasis on verification and validation, and we'll discuss that in this section. We'll talk about the validation master plan or the master validation plan. You won't find that document referenced specifically in the GMPs, but it is a requirement. It's part of the C in GMPs. The FDA has certain requirements that the industry has adopted maybe on its own or maybe through reliance on other guidances or recommendations from inspections, etc. And as a result of that, it's becoming a standard in the industry. And if it is right in the middle of the pack, not bleeding edge, not leading edge, but it's something that's generally accepted by industry as a whole, the FDA expects you as a company to adhere to it, even though it is not written in the GMPs. One example is the validation master plan. Another is quality agreements. Another is a quality manual. Those documents are not specifically referenced in the GMPs, but they were implied by other statements in the Code of Federal Regulation, as well as the preamble to those. So that's part of the rationale. They have to be done. In fact, many times some of these are asked to be submitted to the agency when they announce an inspection before they show up at your door. So we'll look at the various types of validation. We'll look at device or product validation. We'll look at equipment validation, that's production equipment, lab equipment, R&D equipment, and so on, and test equipment. We'll look at processes and validation of processes. We'll look at software validation and quality management system validation activities. And then look at the key areas that the FDA stresses in these areas. And we'll consider various types of protocols and test cases, formats for them in all areas. Now, we'll use the example of the IQ, OQ, PQ, but you're not held to that. You can use other terminology, but you have to cover the areas that would be addressed by IQ, OQ, PQ. We'll define the terms and what would be typical of the type of test cases under each one of those three key qualification areas. And then we'll talk about life cycle, cradle to grave issues as we go through this discussion. So as I mentioned, the C in cGMP means what's current. In other words, industry best practices. So first of all, what is the basic purpose of verification and validation? So the purpose of validation can only be met if you try to replicate reality. Now, if you're dealing with Part 11, electronic records, electronic signatures, Part 11 is used when you're using electronic records and or signatures to supply some record showing GMP compliance, but you reduce risk as low as practical or possible without compromising the fact you don't have a product. So that concludes our first module. Just a quick key point of takeaway from our first module, which carries throughout our entire discussion, is the simplest way to look at a validation is you have a list of requirements, all your total requirements for whatever it is you're validating. Then you determine what are the areas that I have to prove repeatability and reproducibility given variation. So that's the key, to me, the key takeaway from this morning's activity. It simplifies a lot how you do a validation by breaking it down to requirements versus test cases. Now we're going to talk about design control, because design control is the start of a new product or a major change to an existing product. And as a result of that, it also has two elements within the 10 elements of design control that deal with variation or validation. That's design verification and design validation. So we're going to look at 820.30. We're going to look at 13.485, 2016, 7.3. We're going to look at the 10 elements in both of those. We're going to look at what they lead to in terms of your further documentation, like your device master record and your device history record, or your master production record and or lot record, depending on where you're located in the world, what terms you use. We're going to look at some of the similarities between the FDA's requirements and the medical device regulation requirements in Europe, or the old medical device directive requirements. And we're going to talk about the technical file, the similarity between a technical documentation file and a submission to the FDA for device marketing clearance or approval, 510K or PMA. And we'll look at some possible templates for SOPs on design control and technical documentation, especially focusing on the quote-unquote essential requirements / general safety and performance requirements of the medical device regulation in the technical documentation SOP. So let's look at the 510K for just briefly. We're focusing on design control, but a lot of design information goes into the 510K or goes into the technical documentation file. So we'll be discussing ISO 14971 2019 for devices, and I use it as a model for all risk management, even ICH Q9 for pharmaceuticals. I use the same structure for that as well. Now your goal is to determine what are the risks, the hazards, the hazardous conditions. There's a slight difference in meaning in those, each of those words are explained in ISO 14971. We'll get into that as we go along here. You do a risk assessment, and then you manage risk. You try to drive risk as low as reasonably possible or practical, as little as possible with stipulation. A big change here. We'll talk about that as we get into it. You have your risk management file. It talks about the discussion of the issues, list of hazards, and then you're given some choices of documents you want to use later, like HAZUP and others. I settled on fault tree analysis and design, process, and use FMECA in no case. I use FEMA's or FMECA's failure mode effect criticality analysis. And then you have a review and report. You involve a team in this, and I like to have a clinician as part of that team familiar with the procedure and the device on the patient. And then it's a living document under change control, updated as needed. And of course, good documentation practices are involved as well. Now, the goal of risk management is to reduce risk, to increase safety and use. And this affects the design and should be part of design control. Risk assessment. So again, where the FDA is making a determination here, they usually refer to ISO 14971, the risk to the patient. So, or the clinician or the use environment. If they're talking about cybersecurity, that's part of risk as well, but it's dealing with patient risk. If they're talking about risk in general, like software validation is a risk-based activity, they're talking about patient risk, user clinician risk, use environment risk. They aren't talking about financial risk, budget risk, compliance risk. So that concludes our third section, our third module. We're going to get into session number 4, software firmware verification validation. It'll be a good review of general validation, but also focus on the extra additives we put in there for software and firmware verification and validation. So that's what we'll be focused on in this module. And then after this, we'll get into human factors and use engineering, which, unlike risk management, is only done occasionally, or where the interface is unfamiliar to the user. And then we'll get into cybersecurity, the general issues of cybersecurity, the issues of validation of cybersecurity for anything that's networked. And much of systems, of production systems and devices, are networked or capable of being networked. Dealing with risk management under ISO 14971 and people safety under cybersecurity, which is something the FDA is kind of feeling their way around, as is industry, because it's a relatively new threat in terms of hacking worldwide. Nation states are involved, as well as individuals that make their living just doing this. So we'll discuss that. We'll spend a little more time on that as well. But let's first of all give our attention to software and firmware verification and validation. So once again, we'll get into the definitions of term. We'll get into risk-based, the master validation plan, and then much of the discussion will focus on the 10 elements, as well as some of the other requirements, how we weave in Part 11, how we weave in cybersecurity, how we deal with existing systems, and what the FDA looks for regarding Part 11. There's been all kinds of confusion regarding how the FDA enforces Part 11. We'll examine that as well. We'll look at a trade association standard, GAMP 4 and 5, and we'll look at the mandated standard for software, IEC 62304 as well. And not spend a lot of time on that, but look at the test cases, which again are very similar to general verification validation, hardware or equipment, but we'll also focus on the additions we make and changes we make for software and firmware. The goal is to keep this simple in terms of the documentation requirements, so that we understand the key principles involved and spend the majority of our time in validation of really tackling the issues, especially revolving around safety and efficacy. So software verification and validation identifies various issues and concerns, and we need to make sure that address all the requirements are complete. That'd be your DQ. And then the requirements then will drive your test cases. And you'll separate the requirements into the installation area, and then the operational area, and the performance area. Or if there's some of the requirements are dealing with product, then whether it has to be sterile or not, then you pick up the sterility testing and the biocompatibility testing and particulate testing and the functional testing that are not IQ, OQ, PQ, but they're unique to products. And that's part of the requirements that are tested as well. Still, the requirements drive the test cases no matter what. And then you are issued, all your data should be under the principles of data integrity and writing down and recording this information. Cybersecurity methods have to be addressed if necessary. Part 11 has to be addressed where necessary. Commercial off-the-shelf software, there's some data you won't be able to gather, and you have to indicate that in your documentation. The other area where you include that. SOUP software, or software of unknown provenance, you have to make up what is unknown, what is missing, before you can use that software by replicating the testing. And of course, the documents, that should be 10 again. I missed that on several. I thought I went through all these, but you get too familiar with something, you miss it. Sample size justification, and signatures and approvals and dates. As I mentioned, do something. If this is totally new to you and you see the need to do it, jump in there with the recognition you're going to address the key areas of safety and efficacy in your validation. Then later on, flesh out with additional addendums to the validation as you gain knowledge, but get something there. Don't wait for perfection, because that'll never come. So that concludes the fourth module in our discussion, software and firmware. Well, let's go ahead and resume. We have our last two modules. These are shorter modules, obviously, and we're going to conduct them. We're going to start with session 5, use engineering and human factors engineering under IEC 62366-1 and -2. The emphasis on -1. Now, this defines a process for human factors engineering. We're going to be talking about IEC 62366-1, 2015,
dealing with use engineering, and it defines the process for use engineering. And -2 is the implementation of -1. We're not going to spend a lot of time on that. We're going to talk about how it applies. The FDA term is human factors engineering, but the IEC term and the international term is use engineering, and talks about the same issues. And the 62366 defines the process, the what, and the part 2 is the how to do it. But the specifics of human factors, the details of human factors, are left to other standards as well. Sometimes people say, well, we don't really have to follow 62366, we just need to follow this particular standard on human factors or the other. That's incorrect. The worldwide implementation of 62366 is this defines the overall process, and this defines the basic contents of a use engineering file. And then the actual particulars dealing with the uniqueness of your product and the human factors issue of that particular interface of that product are called out in other more detailed standards dealing with the mechanics of human factors, not the process of human factors. So the goal was to harmonize this also with the risk document ISO 14971. If you read it, the 62366, you will find a lot of references to 14971 and similar terminology. So they're used in conjunction. And both documents are to be used in the design of product. So that's the important factor to keep in mind. They're used in design to reflect increasing the safety of the use of product. So the goal is to use it during the design and development. Now, ISO 14971 is used 100% of the time with new products and major changes to existing products. IEC 62366-1 is only used where the interface is not familiar to your user, or there could be misunderstandings with the interface. So you want to test it and try to drive the use of the interface down to its most common level. It's where it's intuitive, if you will. Same thing for risk management. The same issues drive the demand for use engineering. And once again, the key document file is the design history file, the top level file, risk management file mandated 100%, and use engineering as needed. Supplemental files to the design history file. So that concludes the fifth of our 6 modules. Okay, we include cybersecurity here because virtually everything electronic now has the capability of being networked. Devices do, they have to be validated to that, and production equipment does, and quality management systems do frequently. The systems that are created by companies are designed to be, in many cases, interface with the cloud, so a direct connection to the internet, and cybersecurity comes into play. So I include it here because it is a major component of safety concerns regarding the product. So we're going to look at cybersecurity. We're not going to spend a lot of time on this. We're going to look at part 11 as part of it, 62304. We talked about that. We're going to focus on what the FDA defaults to as NIST recommendations, National Institute of Standards and Technologies, or Science and Technologies. And then the role of updates and patches, the problem with the system administrator, and validation issues and submission requirements. So this is a new area. The FDA's reaction to it is just that, a reaction. It's changing constantly in view of, like we saw, that last document came out just a couple months ago. This has been frequent new guidance documents coming out periodically, draft documents, final documents, reflecting the newness of this to the agency and to the industry. So that concludes my entire presentation for the day. All 6 modules, that master validation planning. Then we talked about design control and product V&V. Then we talked about product risk management, where everything has to be dealt with on a risk management file, every device. Then we talked about software and firmware V&V, which built upon the first module on master V&V planning, but geared to software and firmware. Then we talked about human factors, which is not used all the time. Risk management is, human factors is only where there's interface issues that need to be addressed to make them simpler and more intuitive. And then cybersecurity, that's becoming increasingly a requirement of all, because virtually everything is designed to be interconnected and interact to the network, to the internet, to the cloud. Your software, your operating systems are downloaded from the cloud. Information storage is stored in the cloud. You have that on your own computer. A lot of things stored automatically to the cloud if you don't discount that when you fire up a new computer, and so on and so forth. So this is why we discussed all these various topics involved in verification and validation, a lot more than you might have thought initially. Thank you for your attention. Once again, I thank you for your attention, and we'll sign out now.